Good morning, guys. I'm sorry I'm not here again today. We're going to try to keep it short and sweet when it comes to the math workshop. We're only going to do number 5. I understand you don't know how to do 6 and 7. We'll deal with those later. If you're trying to get ahead, go ahead and think about 8, 9, 10, 11, 12. Especially on 8 and 10, remember that if you have a negative under the radical, you need to involve I. Okay, so on number 5, it's a very special thing. I mentioned it to you on Friday. That number 4 was the difference of perfect squares. And this one is the difference of perfect cubes. In fact, what I'm going to show you works for when there's a minus sign in between two cubes. It would also work if our problem had a plus sign between two cubes. We're going to work a couple examples of this, not just number 5. I'm going to do it on Post-its. If you would like to flip to the back of your notes to write this down, that would be oh so wise, because you are expected to know this from this point forward. Okay, so you would think if you're just trying to logic your way through life, you know that 2 to the 3rd is 8. So you would think, hey, maybe this is supposed to be x plus 2, x plus 2, x minus 2. And if you FOILed this out, you would be sorely disappointed. Or maybe if we tried with the positive version, so x to the 3rd plus 8, you're like, well, maybe when it was a minus 8, darn sign's messing me up. Maybe if it's plus 8, it's always going to be x plus 2, x plus 2, x plus 2. And again, you will be highly disappointed when you FOIL that out, because that is not the case. Sadly, cubes do not follow the pattern we wish they would. Instead, what you need to learn is an acronym called SOAP. Yes, SOAP. So SOAP. The S is for same, so same sign. The O is for opposite. And then the A is for always. And the P is for positive. Okay, so back to our problem of x cubed minus 8. We thought it was going to be 3 binomials, meaning there are 2 terms here, 2 terms here, 2 terms here, and there are 3 in total. So we thought it was going to be 3 binomials. That's actually not the case. The answer ends up being a binomial, yes, but not 2 other binomials. It ends up being a trinomial. So this one's going to have 2 terms, and this one's going to have 3 terms. Okay, and then our SOAP acronym can already tell us the signs in between. So same sign, meaning the same as the sign in our problem. So same sign would be a minus. Opposite sign, well, opposite of a minus is a plus. And then always positive, that is a plus. So seriously, the SOAP acronym has helped us decide it's going to be a minus sign, a plus sign, and a plus sign. And we just have to decide what numbers or variables to put in those missing slots. Okay, and I swear we're going to work a couple more. So it's okay if you're like, why is this working? Okay, so we assumed it was going to be just an x. And again, we understand the cube root of 8 is 2. So it is just a 2. So the first term, yeah, that makes sense. The second term, we actually take x. So again, you and I think we're involving x's and 2's. And we're right. So we put in an x, we put in a 2. We're actually going to do x squared right here in the front. 2 squared right here in the back, so 4. And in the middle, we're going to do x times 2, which would be 2x. So again, we're just involving x's and 2's because we understand x to the 3rd is this. 2 to the 3rd, well, you know, a sign difference, but it's that. And so that's why we're doing x minus 2. This one is x squared, 2 squared, 2 times x. Okay, so let's try a similar problem problems. Let's try one similar problem, such as x to the third minus 27. Well, we understand 3 cubed is 27, so we're assuming our answer is going to involve x's and 3's. Okay, and thanks to that SOAP acronym, same sign, so it's going to be a minus. Opposite sign, so it's going to be a plus next. And then always positive for that last term. Okay? And then to fill in the blanks, it's going to be an x and a 3. X squared, 3 squared, x times 3. It will even work, let's do one more like that. So x to the third minus, where are my cubes today? 64. So I know that's x, and 4 to the third is 64. So again, the hardest part is to think through that SOAP acronym. Same sign, opposite sign, always positive. I know it's going to be an x and a 4, x squared, 4 squared, x times 4. Okay, and then, it couldn't kill us to work at least one or two that have a positive sign in the middle. So x to the third plus 8. Well, again, that SOAP acronym, same sign, so it needs to be a plus 1 here. Opposite sign, well, opposite of positive is negative, and then the last one's always positive. So things have changed a bit because of that plus in between the x to the third and 8. But still, I'm still thinking x and 2, because 2 to the third is 8. So it's an x and 2, x squared, 2 squared, x times 2. Last but not least, we'll do the same thing, but with 27. Maybe, I don't know, I'm running out of post-it room. Yeah, I'll leave that one. You can see it if you weren't done. My bad. Okay, so same sign, opposite sign, always positive. I know this is x and 3 because 3 to the third is 27. So it's x, 3, x squared, 3 squared, 3 times x. And seriously, this is always going to work with cubes when you recognize that you have a perfect cube going on with you. It's creepy, I know. So that's the thing to put to your memory tonight. That's why we're only doing the one. So you've got to remember to always use SOAP. Yes, in real life, but also when you're dealing with differences of cubes. Okay, have out your notes, please. We're actually going over something different today. Instead of long division, we're going to let it go. Well, we're not going to let go division of polynomials. We're just going to learn a different method today, which I know you'll be super excited about. Let me get out my notes. Okay, so for being honest, long division can be a pain in the rear. Okay, we skipped number 5. Let's do it quickly. We're actually not using long division for this one. As discussed, we're thinking that we can pull out what's in the denominator out of the numerator, and I bet we can. So in the numerator, can we factor out 3n squared p squared? Well, if we factored that out, we would be left with our first term, 3n p. For our second term, it would be minus 6, no n's, no p's. For our third term, it would be plus 7, no n's, 1p. Divided by 3n squared p squared. Let's see if this comes to do math this morning. Those cancel out. So unless for some reason I've gone completely blind, my answer is 3np minus 6 plus 7p. If you want to rearrange that and put the minus 6 at the end, I totally understand. Okay, now let's move on to our next problem. So long division's great. Always works when reliable reliable method to help you find the answer when you're asked to divide polynomials. Love it. But, gotta admit, it takes a long time. Is there a faster way? Absolutely. And that's what we're going to discuss today with synthetic division. If you think you can turn in your Mad Libs using synthetic division, now that we go over this, you're wrong. You got a new puzzle coming your way to practice synthetic division. The Mad Libs were specifically for us to practice long division. Now, after today, I'm not going to be like, well, I don't promise that the test might say solve by long division, so you have to use long division. For the most part in real life, after today, you get to choose which method, and I'll tell you which method I like and when. Okay, so synthetic division kind of looks a little funky. Okay, so we end up, it's as if you were to think through, what if we set x minus 4 equal to 0? We would then say x equals 4. That's the number we're going to use. We're going to divide 4 into our terms. And what's really cool about synthetic division is we don't have to bother writing like x to the third, x squared, x. We don't have to write any of that. We just put the coefficient in front of each one. So for instance, the number in front of, the number in front of the x to the third is a 2. The number in front of the x squared is a negative 13. I got a 26 and a negative 24. So since I'm on a roll, I was being smart, I go ahead and set up the next problem. So in my mind, I don't even write this part down. I just think through it. It ends up being the opposite sign. So I'm going to divide 2, not minus 2, but 2, into, and then I've got to write down the leading coefficients of the others. Now I wish you were here to help me because this one is a little harder. And if I asked you why it's harder to set up number 2, I pray you would say something about the fact that some of the exponents are missing. We don't have a g to the third. We don't have a g to the first. So we're literally going to have to put in a 0 as a placeholder. So I've got 1g to the fourth. I've got 0g to the thirds. I've got negative 3g squared. I've got 0 g's and a negative 18. Okay, if you need that slower, which trust me, I understand. It's 1g to the fourth plus 0g to the third minus 3g squared. Okay, so what am I writing? 1g to the fourth plus 0g to the third minus 3g squared plus 0g minus 18. Hence why the numbers I wrote below were 1, 0, negative 3, 0, negative 18. So seriously, the hardest part of synthetic is setting it up. And then also remembering this weirdo method is a little difficult. Again, it's much faster than long division, but long division to me feels more natural. Okay, with synthetic division, we do some weird stuff. The first thing we do is we always drop down that very first term. So drop down your 2. Then we say 2 times 4 is 8. So seriously, you have to remember to drop down the first term. But from here on out, I'm just going to multiply. So 2 times 4 is 8. I get to add straight down. Negative 13 plus 8, that's negative 5. Negative 5 times 4, that's 20. Negative 20, come on, let's count that. Negative 5 times positive 4 is negative 20. When I add straight down, 26 minus 20 is just 6.
If you're in the building, please come to the main office. Betty Stewart, Mr. King.
I mean, even when I'm not here, I can't avoid it. I don't understand. Okay, whatever. 6 times 4 is 24. And when I add those straight down, I get a 0. And that actually means we have a remainder of 0. So we're excited because we're not going to have to deal with the remainder on this problem. Okay, you're like, that's great. I understand you drop down the 2. 2 times 4 is 8. Negative 13 plus 8 is negative 5. Negative 5 times 4 is negative 20. 26 minus 20 is 6. 6 times 4 is 24. Negative 24, positive 24, we end up getting a 0. this line makes sense, but you're like, but it doesn't have x's, so that can't be the answer. And you're correct. So we actually end up dropping it down an exponent. So our original problem was x to the third. So with our answer, we're going to start off with x squared. So if our problem had started off x to the 20th, we would start off x to the 19th. Thankfully, nothing's going to go that high for us. But anyway, so it was x to the third. We're going to drop down one exponent and be at x squared. So 2x squared minus 5x plus 6 is our answer. So if you're really questioning me this morning, as someone probably should, if we wanted to take x minus 4 and actually distribute and combine our like terms, we better get our original problem, or else I've done something wrong. So again, our answer is 2x squared minus 5x plus 6. But if you wanted to check, which, Lord, I don't feel like it. Maybe you want to. If you wanted to check and do x times this, negative 4 times each of these, combine your like terms, etc., you should end up back at our original. Now again, this one works out nicely because the remainder is 0. If we had a remainder, let's say we had a 3, we would still have to do 3, instead of doing 3 over 4, which I know is where your gut wants to go, you would have to do 3 over x minus 4. You have to go back to what we were originally dividing our polynomial by. We weren't dividing our polynomial by 4, we were dividing our polynomial by x minus 4. Okay, I hope that made sense. If not, we're doing another, so yay. Number 2. So we drop down that first term. So we'll have a 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2, that's 4. Okay, I did that kind of fast. I dropped down my 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. 1 times 2, I get 2. 0 plus 2, I get 2. 2 times 2, I get 4. Negative 18 plus 4, I get a negative 14. Okay, so this time we actually have a remainder of negative 14. I can't spell out remainder, so I'm just going to put rem. Okay, so when we write our answer, we need to involve the g's because that's our variable. It was g to the 4th. We're going to drop down one exponent in our answers. So it's going to be g to the 3rd plus 2g squared plus g plus 2. So the 3rd, the 2nd, the 1st, just a number, and you're like, but what about the negative 14? Well, yeah, we agreed that was the remainder. So I'm going to do minus 14 divided by what we were dividing by, which is g minus 2. So we're getting the same answers we were getting if we had used long division, but this is a tad bit faster. Okay, I'm going to do the number 4, the guided practice, because you've got some problems of your own that are going to be your guided practice. Okay, so b minus 2, that means I'm dividing positive 2 into, this is the opposite sign. I've got a 6 to the 4th, negative 8b to the 3rd. I don't have a b squared. I have a 12b and a minus 14. I drop down my 6. 6 times 2 is 12. 12 minus 8 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 12 plus 16 is 28. 28 times 2, whoo, I'm going to do math this morning, and that 56. And then 56 minus 14, brain, please work now. I drop down my 6, 6 and 2 is 12. 12 times 8 is 4, 4 times 2 is 8, 0 plus 8 is 8. 16, 18, 56, minus 14, and that is 42. So again, we have a remainder. So when I write my answer, I drop down one exponent. So it was b to the fourth. My answer is going to be b to the third for the first term. Then 4b squared for the second term. 8b for the third. Plus 28. And then you're like, what about the 42? Don't forget that is the remainder. So 42 over what we're dividing by, which is b minus 2. Now, you can see how life is so much faster with synthetic division once you get the process down. And I use synthetic division anytime, when I get to choose. I get we don't always get to choose in life. We have to do what the teacher says when she says to do it. When I get to choose, though, if I have a leading coefficient of 1 in my binomial, the way we have on each of the problems we've worked so far, I'm all for it. Synthetic division is awesome. However, when we don't have a leading coefficient of 1, like on number 3, when we have a leading coefficient of 3, we're going to end up being in fraction land. And I don't know about you, but sometimes I'd be better with long division than living in fraction land. Just saying. Okay, so we're living in fraction land. Oh, Lord. So, again, I think you're in my head. I know I've been doing it just out loud. So, it's, in my mind, I'm thinking through this. So, x equals negative 1/3. So, I'm going to do negative 1/3 and then I'm going to list out my things as usual, like we've been doing in the other problems. So, we can already see we're off to a terrible start because we're going to end up multiplying everything by negative 1/3 this second, which could be potentially a giant pain. It might all work out for us because I'm thinking 3 and negative 1/3, they do end up canceling out, but you never know. Okay, so we've got a 3 x to the fourth minus 5 x to the third, a 1 x squared, and a 7 x. Okay, I get there is no, what was I going to say? I get that there is no constant term, so we can use a 0 here if we'd like as well. Because we have an x, we have a 4, 3, 2, 1, we don't have an x to the 0, so if you want to put in the 0, of course. Okay, so we can roll with it from here. So I can drop down my 3. Well, this one actually works out nicely for us because 3 times negative 1/3, you end up getting negative 1. That worked out nicely. Again, if you need to put these fractions in your calculator, remember we pressed that, I don't know which buttons were, fraction. Alpha y equals b for the fraction button. Okay, so negative 5 minus 1, I get negative 6. Negative 6 times negative 1/3, well, it ends up being positive 6 over 3, which reduces to 2. 1 plus 2 is 3. 3 times negative 1/3, well, again, I get negative 1. 7 minus 1 is 6. And then 6 times negative 1/3, I get a negative 2. So I drop down my negative 2. Okay, so my answer is 3x to the third, because it was an x to the fourth, I dropped down 1, minus 6x squared, plus 3x plus 6 minus 2 over 3x plus 1. Okay, and on this kind of problem, me and your textbook disagree. Your textbook tries to avoid, it ended up working out nicely with this. Your textbook tries to avoid dealing with this fraction entirely. So, to begin with, it divides every single one of these terms by the negative 1/3. And so their answer is a little different than mine. I think their answer is, you see how we could pull out a 3 out of the first. So we have the same remainder, but their answer is x to the third minus 2x squared plus x plus 2, because they pulled out that 3. I think that's weird. I don't know about you. ask Miss Brewster, maybe she has a different suggestion on how to handle this beast. Again, when I get to choose, anytime I see something that does not, it's not a 1 in front of the X, and we're asked to do synthetic, I say, oh, pass. I don't think so. Okay, I'll do number 5 quickly, but anyway, moving on. Okay, so 3c minus 4, if I set that equal to 0, I would get c equals 4/3. So I'm wanting to do 4/3 into 6, negative 17, 6, 8, 3, 2, 1, 0. Okay. So I can see the textbook point about dividing each of these by 4/3 first. Fractions really don't scare me, but I could see if you don't like them why you would want to do this. Okay, I bring to my 6. 6 times 4/3 ends up being 24/3, which reduces to 8. Negative 17 plus 8 is negative 9. Negative 9 times 4/3, negative 36/3, and ends up being negative 12. 6 minus 12, I get a negative 6. Negative 6 times 4/3, I get negative 24/3, which again reduces to 8, negative 8. And so I actually have no remainder on this problem because my last thing's a 0. So it was to the third, so my answer is 6c squared minus 9c minus 6 with no remainder. Yay. But again, I totally understand if you're annoyed with the fractions and you're like, I would just rather do long division. And I agree in life. Okay, I've rambled on long enough. You know your math libs are due today. We're going to be handed a new puzzle. It is not due today, but it would be wise to go ahead and get a head start on that. Okay, have a good day.